Hello, welcome back. This is the second video solving model exam. For today, the first question, it says, which one of the following is equal to the limit of what you see here? Square root of 3 plus x minus radical 3 over x as x goes to 0. Direct substitution here doesn't work because if you insert 0, the denominator is going to be 0, which will be undefined. So what to do? We are going to rationalize the numerator, not the denominator, because the numerator contains radicals. So what to do? There are two radicals here combined by minus, so I have to multiply by the plus of it. So square root of 3 plus x plus square root of 3, the whole over both the numerator and the denominator will be multiplied. Square root of 3 plus x plus radical 3. Then what's going to be the outcome? Let us see. Remember the formula. When you multiply a minus b times a plus b will be, it is the same as a square minus b square. So here the same case. If you consider this one like a, this one b, so a minus b is there, and consider this one a plus b form. So I'm going to take out the, when you multiply, okay, a square minus b square will happen. When you square, the radical will be removed. Therefore, it's going to be 3 plus x minus 3 remain up. Denominator, when you multiply x times the multiplier here, it's going to be x in bracket square root of 3 plus x plus radical 3, which is equal to, now at the top 3 and negative 3 cancel, and what remain? X over x in bracket, just write as it is, 3 plus x plus radical 3. This is the whole over. So as you see here, x cancelled out. This was the problem. Now we can find the limit. So the limit of this thing, what left up? 1 over square root of 3 plus x plus radical 3. As x approaching 0, this time we can directly insert 0 because it doesn't have affect us. So it's going to be 1 over radical 3 plus radical 3, because 3 plus 0, so it's going to be 1 over 2 radical 3. So the answer is going to be B. The next question, it says, what is the length of the latus rectum of a hyperbola? Length of latus rectum for hyperbola is, don't forget, is 2b square over a. That's the formula. So first of all, we need to write the given equation, the equation of hyperbola in the standard form. So for that purpose, let us shift the constant first to the right side. So it's going to be 25x square minus 36y square is equal to 900. Then the next step, divide each of them by 900 to make the right side 1. When you divide by 900, what will happen? This will cut out and 1 remain to the right side. What about the left side? You can simplify. You can simplify by 5. This will be 5. You know, this by 5, it will be 180. Again by 5, when you simplify, it will be by 5 1. This by 5 36. So x square over 36 remains, minus the next one y square, because if it is 36, the other one will be 25, obvious. So what to do? Y square over 25 is equal to 1. You'll have this. So here a square is equal to 36, the denominator of the first, and b square is equal to 25. We do have these two. We are looking for a and b actually. B square, we go to utilities. What about a? From this we can get the a. A must be 6, you know, when you put both sides in the radical. Therefore, the length of the latus rectum, that's what we are looking for. The length of the latus rectum will be 2 times b square is 25, the whole over a. The a value, it is 6. So you can simplify here. When you simplify, by 2 1 is by 2 3. So what left? 25 over 3. That will be the answer, which is D. Let us go to the next one. The next question, it says, which one of the following compound proposition is contradiction? Contradiction means always, it cannot be always true. Tautology means always true. For example, the first one, when you see A, P implies Q by imply negation of P or Q, it says. But remember, negation P or Q, it is the same as P implies Q. So that means the two are the same. Okay, P implies Q and negation P or Q. But negation P or Q is the same as P implies Q. Therefore, the two are equal. The two are the same. So in case of by implication, remember, in case of by implication, if both true or if both false, the outcome will be always true. So if the two the same means, okay, the right side and the left side of by imply, if both are the same means if this true, this will be true necessarily. If this one false, this is going to be false. That means it can satisfy the condition always true. This is always true, because whatever P, the truth value of P or Q, whatever it is, if the whole this one, if it is the same as this, that means it will be the outcome of the whole compound statement is going to be true by imply true or false by implies. Because if this part true, the right hand also will be true. If this false, false. So the answer is going, this is also, this is the choice A will be tautology. It is always true. It's not contradiction. When you come to B, it says P implies Q. Okay, it says P implies Q, then by implication, negation Q implies negation P. Don't forget that. The two, as you see here, P implies Q and negation Q implies negation P means they are the same, they are equivalent, because negation Q implies negation P means it's the contrapositive of P implies Q. So contrapositive of a given implication, it's going to be the same as the original one. So P implies Q and negation Q implies negation P, logically they are the same. So that means, as I said before, the same, like if this part true, this is going to be true because they are the same. If this false, necessarily this will be false. So they are combined by imply. In case of by imply, if they do have same truth value, the whole the compound statement is going to be true. So again, this is going to be tautology. It's always true. Okay, the next part. Okay, when you go to C, first of all, let's make it clean and let us see part by part. Again, C is also, it's by implication, but after by implication, what's written there? What you see here, P and negation Q. What means P and negation Q? This is the same as, you can take out negation outside, and this is positive, so it's going to be negative P, and the end will be changed into or, and Q remained positive, because like that of extracting negative. By De Morgan's rule, if you distribute this negation of negation P will be P, and the or will be changed into end, and negation of Q remains. So they are the same. This is the same. And what does this mean? As I said before, this means P implies Q, but the negation still remain outside there. Now, what is the statement given to you? I mean, the compound proposition there. P implies Q by imply negation of P implies Q. That means this one and this one, they are not the same, like that of A. To be tautology, it has to be the same, but this is opposite. If this is true, necessarily this must be false. If this is false, necessarily the other will be true, because negation is there. Therefore, this is always false. Always false. That means it's contradiction. So the answer necessarily will be C. I will repeat once again. What did I do? Just I detach the second part here, and I brought it. Here it is. Here it is. Then I try to apply De Morgan's rule. I take out negative, like for example, if you have 3 plus negative 2 if you have. What to do? We can take out negative outside. The negative, when you take out outside, the positive will be negative 3, and this plus will remain 2, because plus negative means, you know, it's negative. So like that, when you extract the negation outside, what left here? Negation P or Q. The end will be changed into OR. Don't forget that. We cannot like say it directly like that way, but by according to De Morgan's rule, end is going to be changed into OR, because when you distribute the negative, that's a rule. Therefore, the negation remain outside. But what does this mean? The inner bracket here, the inner bracket is the same as equivalent to P implies Q. I wrote it here, and the negation outside is still there. Now try to see the two compound proposition before and after the by implication. The before one, it's P implies Q, as you see here. The after one also, it's P implies Q, but it's negation. That means if either of the two is true, the other will be necessarily false, because it's negation there. That means the two are not always the same. They are opposite. So in case of by implication, true false or false true will be always false. It has to be same truth value to be always true. So A and B, they are always a tautology, but C, it is contradiction. What about D? You can check. By the way, P, Q and negation Q, it's false. False or P means it depends on P. We cannot say it's always tautology, or we cannot say it is always contradiction. I mean, we can say this one, it's always true or always false. Again, I will repeat it. When I come to D, Q and negation Q means it's false, because in case of end, end is very sensitive for to be false. So it's end. So it's going to be false, because either of the two will be true, and then necessarily one of the two will be false. So in case of in case of end, if one of the two is false, it's going to be false. So or the out part is P. What is the truth value of P? We don't know. If P true, the whole outcome will be true. If P true, it will be tautology. If P false, it will be contradiction. So we cannot decide. So the answer will be C. When you go to the next question, it says which one of the following is divergent sequence? Divergent sequence, to check the divergency of a given sequence, what to do? You are going to find the limit of each sequence as n goes to infinity. So first of all, when you go to A, it says 1 plus n over 1 plus 3n the power of 4. So what is the limit of this sequence as n goes to infinity? As you see, the highest exponent of the variable is n to the power of 4. So divide each of them by n to the power of 4, each of them. So it's going to be 1 over n to the power of 4 plus 1 over n cube, because 1n will be cancelled. The whole over, again here divided by n to the power of 4, it will be 1 over n to the power of 4 plus 3 remains. Then when you substitute infinity, or when you insert larger number in place of n, this is going to be 0. Each of them will be 0. So what remains? 0 over 3, which is 0. This is that means sine 0. You know, sine 0 will be 0. So it's convergent. This is 0. It converges to 0. That means the limit as n goes to infinity. We are trying to find as n goes to infinity. This, the same for all. When you go to B, if you substitute like as n gets larger, it is going to be large number. So negative 1 or 1 over large number is going to be 0 again. Negative 1 or 1 doesn't matter. Either negative 1 over 1 over large number, almost it will be 0. But when you go to C, it will be somehow different. Why? Because if you insert large number here, 1 minus large number will be negative of very large number. So this negative, when you flip 5 up, it will be 5 the power of positive large number is going to be. That means it's going to be a larger number. We cannot deduce, or we cannot conclude what is the number, because remember, again I will repeat it, we are focusing on n, because we are talking about the limit of this sequence as n goes to infinity. So I'm going to substitute in place of n a very large number, like any bigger number. When you insert here 1 minus that large number will be almost the same number, but negative of it, negative of very large number. But this negative we can remove it. How? By bringing up the 5 up. It's going to be 5 the power of the large number. Now 5 the power of large number means, imagine even 5 square is 25. If you consider 5 the power of 4, it's going to be 625. Even 4 for large number, the outcome will be very large. it's expanding or getting larger and larger. So this is not divergent. I mean, this is divergent. It's not convergent. This is a divergent one. If you go to D the same manner, divide by n square all, so you'll get 0. It will be convergent. So the answer will be C. The next question, which of the following is a valid argument? There are premises given to you. So which one is divergent? Okay, which one of the following is valid, it says. To check the validity of a given proposition, first of all, consider the premises are true. Okay, what is the premise in A? P bar implies Q and P implies Q are premises. These are true. Okay, consider or assume these are true. You are going to assume always the premises are true. Then you are going to check from this given condition, can we conclude that Q will be always true? If it's Q become true, we can say it's valid. Again, I'll repeat the statement. What do I say? Okay, considering P implies Q or the premise, these two premises. There are two premises, they are separated by commas. Okay, considering or assuming the premise as true, can we conclude that the conclusion part means after this bar? The conclusion part, can it be true? Can we be like we can we be sure that the conclusion part will be true? Let us check. Now P implies Q, true means either both true or both false. We don't know about P or we don't know about Q each, but we can say that both must be true or both must be false to make the whole statement true. Okay, what about the second part? P implies Q to be true. There are many preconditions: true true or false true or false false. It will bring true. But what makes false? P true and false, Q false. We cannot deduce or we cannot conclude about Q this time. We cannot discuss because the given precondition doesn't tell us about Q. Okay, let's go to B. When you go to B, one of the premises it is P implies Q. This is true, and the other premise is Q. This is also true. If Q true, here it is. If Q true, can we say about P? To say the whole true. P can be true because true implies true will be true, obvious, because as a premise the whole true, this one. And Q we got it for as a premise again alone. Q is true given to us. So keeping Q as a true, what can you say about P? P can be true or false. Because if P true, true implies true, it will give us true. And if P false, false implies true also will give us true. Because in case of implication, the only false case is true implies false. Otherwise, if the conclusion, the conclusion part false means the premise, it can be anything. True, false, if the conclusion part already true. If the conclusion part already true, the premise can be anything to be the whole true. So already the conclusion here, as you see, the Q is true. So we cannot say about Q. We can't say it's always true. So it's not valid. This is not valid, this is not valid. When you go to C again, there are three premises. Negation P, one premise. This is one premise. The other premise is P or Q. And the third premise is R implies Q. So we are going to check for R. Okay, negation P true. This is also true. And this is also true. All of them, the premise consider always as true. Okay, if negation P true, what will be P? It's going to be false. If P false, necessarily the Q must be what? True, because the whole is true as a premise. So Q must be true. Okay. Now, if Q true, what can you say about R? We don't know, like that of P. Because true, if the conclusion part here, for the whole true, the whole thing is true as a premise. But Q become true. What can we say about R? It can be true because true implies true is true. It can be false also R, because false implies true also, it is going to be true. Therefore, again, we cannot conclude about R, so this also, we can't say it's valid. That means necessarily the answer must be D, but let us see how to do. See, it says negation P and Q. This is one premise. The other premise is Q implies R. and the conclusion part is R. Let us check. This is true given as a premise. That means this is also true as a premise given. It's end, remember here. In case of end, to be true, the whole true, it's end here. The whole to be true means each of them must be true. That means negation P is true and Q also true. Negation P true means P is false. Okay, that means let us bring true here because we got it from here. If this true, necessarily R must be true to say the whole true, because as a premise already we said it's true. It's implication. In case of implication, true implies false. True implies false. It will give you obviously false. This means it's false. This means it's false. But we know that Q it is true. And the whole it must be true. It's given because it's premise. The whole it is true. So what must be necessarily R? R must be true. This must be true. That means this is valid. Considering the premise as true, what can we say about R? R must be true. So it's going to be valid. So these are some of the questions that I select for you today. I will continue with another video. Thank you for watching.